Okay, kids, let's look at some examples of the climate system vicious circles, but this time with figures. We already used one figure. Here is a runaway freeze, also known as ice albedo feedback. We already talked about many times. What is runaway? It means it keeps going in one direction till things get very bad, and then there is some break in the system that comes back, brings the system back. So you're looking here at a schematic of an earth that looks very white. All the land is looking white, no vegetation, ocean is looking white. This is an imagination of a snowball earth, which we mentioned, where in the past, remember, Silurian, Devonian, 400 million years ago to 300 million years ago or so, as plants began to evolve, when they started to take up more and more CO2 and started to produce, carbohydrates, hydrocarbon, sugar, plant photosynthesized material, which locked up the CO2 from the atmosphere and got buried and buried and buried. And CO2 reduced in the atmosphere so much that you began to build ice and snow all the way into the lower latitudes, maybe even in the deep tropics and the equator as shown here. That was called a snowball earth, and with the detective work we can do using all the past chemistry and the other evidences we saw about the moraines and the glacial striations and so on, we can estimate there have been maybe 3 snowball earth episodes that you don't need to worry about. But here we are, and how it works. Since it's a vicious circle, you can start anywhere. Let's say we have a colder surface for some reason. Let's say the Earth's orbit changed at that time because there were no human beings around to make climate change. So naturally things happened, and the energy coming from the sun changed in a way that it started to cool the surface, which then went on to produce ice cover, or it increased the ice cover that was already there. And it is especially so over the oceans, where you grow sea ice. Remember, on land we grow snow and glaciers by compressing the snow, but on the water, in lakes and oceans, we have to build ice, which is frozen water, and that increases the albedo, or makes the surface brighter. You can see it looks bright white, so more of the energy from the sun is reflected back to space, which means the surface gets even colder, which will make the ice grow even more, and oceans to be covered more, and soon the energy from the ocean is even not going out to space, and then you have soon ice and snow coming all the way down to lower latitudes. If you're curious to say, then how did we get out of this snowball earth, Grandpa? Then you say, well, there are volcanoes everywhere, and there were volcanoes everywhere that were still throwing out CO2 and other chemicals through the ice, and because that couldn't sink into land and into the ocean, it just started to build up in the atmosphere, and slowly the warming started, because those are greenhouse gases, and the greenhouse gases started to collect more and more of the thermal energy in the Earth's system. So even though ice was trying to reflect sunlight, you started to trap more and more energy, and the ice began to melt. Once it began to melt, what happens then? The surfaces get darker, and the temperatures get warmer, and more ice and snow melts. Then you get more darker surface, and more energy is trapped from the sun, less is reflected, and then soon you have warming and warming and warming. So you get one vicious feedback, or runaway freeze, and the same ice albedo feedback, when it goes in the other direction, can give you runaway warming, which is what we are doing now. Because we are increasing greenhouse gases, we are melting glaciers and making surfaces darker in many places, and that is maybe trapping more energy and making it warmer, melting more glaciers, and so on and so forth. So here is a nice image of the snowball earth with little pieces of ocean open, because we know that even when there was snowball earth, there was still biology happening, which means there was light going into the oceans to allow photosynthesis to happen, and so on and so forth. So it's a very nice detective work that scientists do, and there is a book called Snowball Earth, which is by, I think, Jim Hoffman maybe, and Dan Schrag. You can look it up. Okay, so there are other examples. Arctic is the Earth's air conditioner right now because it has lot of sea ice which reflects lot of the sunlight, and very little is absorbed in the open patches, and the polar bears were happily wandering around, so ice and snow reflect most of the sun's light and heat back to towards space rather than absorb it. So that cooling at the Arctic is flowing down into rest of the planet. So Arctic can be considered as the Earth's air conditioner. By protecting the Earth from absorbing too much of the sun's heat, Arctic ice helps keep the whole planet cool. It's part of the energy balance that we talked about. But if we start melting sea ice and make the pond larger, we begin to absorb more and more sunlight. As you can see, it was small here and the yellow patch was not there, and now we are absorbing more sunlight, making it warmer, which means more of the Arctic ice will be lost, and soon you are absorbing more and more. Absorbed sunlight, absorbed sunlight, absorbed sunlight, sea ice disappeared, and there is the polar bear, which sometimes has to travel for days, swim around for days to find a piece of sea ice to sit on and do its hunting and so on. So as ice melts, less heat from the sun is reflected and more is absorbed by the ocean. So I think it reinforces your concept of positive feedbacks, unstable feedbacks, because they will keep on creating runaway warming or runaway cooling. But it's not this simple. There are many other feedbacks in the system. So you have to be aware. If you don't understand these, don't worry. I'm just pointing it out to say that it's not just ice and albedo and warming and ice melting. There are always many other things. The moisture travels from latitude to latitude, albedo changes, and of course there is atmospheric heating happening, and heating expands from low latitudes to high latitudes. We call it the tropics expanding, which means hurricanes can go further and further to higher latitudes instead of saying just in the low latitudes. And you change the seasons, so the snow melting can start earlier and freezing can start later, so you will lose the ice building in the oceans, and you will have feedbacks to the water vapor in the atmosphere and the clouds, and clouds will reflect more sunlight or less sunlight, clouds will increase or decrease. So you perturb something somewhere and you have many loops going on. So Earth system is very complicated, which means we don't always know what happens if we do one thing here. What else it will cause? It's very difficult to understand. There are many vicious circles in the system. So just remember that every time you consume energy, you waste energy, you waste food, and you drive too much unnecessarily, or you fly around too much unnecessarily. I say drive too much unnecessarily because your parents have to go to work, you have to take the school bus. So right now there is not many things you can avoid, because all our energy is coming from burning fossil fuels and producing greenhouse gases. But as we increase solar energy and wind energy and hydroelectric and nuclear energy and wave energy and so on, we will begin to reduce our emissions. But you have to see how much you are contributing. Not worry about it, not get anxious, but just be curious. So there are many feedbacks, which means every little thing we do affects the Earth system, and if all of the people are doing something that is bad, then it can snowball into a bad thing for the planet. Here we mean snowball in the sense the vicious circle keeps getting amplified, right? So this concludes the chapter on I accidentally hit pause, so I should continue. So we finished this chapter on vicious circle. What comes up next, what we have next is chapter 7. The question is all this climate change real? We already said there are people who don't believe in climate change, or they say, well, this is happening naturally, we have nothing to do with it, or they say what we are doing is not so big that we can perturb the giant planet and its climate system, which means it is a political issue. Some politician may say, don't believe the scientists, they don't know what they are talking about. So these are complicated issues. So we'll look in the next chapter about how do we know if climate change is real, and then we'll talk a little bit about the politics of climate change. You may be too young, but unfortunately you have to at least listen and be aware of all the things that happen when we mention climate change, and then you have to grow up to think for yourself and say, what does science say? What do you want to believe? And if you don't believe, will nature really care? Will climate change continue to happen even if you don't believe? And then what does that mean if climate change happens and bad things happen? So we'll continue the discussion in the next podcast. Okay.